Hi, and welcome to Hydrograph Revision. In this clip, we'll look at how to describe and how to explain a hydrograph, because those are the two questions that you can really be asked. Description first. Well, on the graph you'll see there's a bar chart, and the bar chart represents rainfall and is measured in millimeters. Make sure you use the correct scale. Now, using the bar chart, you can see where the rainfall reaches its peak, in other words, when the rain was heaviest. The next feature to be able to identify is the rising limb. The steepness of the rising limb shows how quickly the discharge of the river, that's the cubic meters of water moving through the river's course per second, how quickly that rate climbs up. The discharge reaches its maximum at the peak flow, and then the discharge begins to sink back down the recession limb back towards a normal level. Now, on your screens you have the advantage of colour. In the exam this will be in black and white. However, the green line represents overland flow, otherwise known as surface runoff. In other words, the green line represents water flowing over the land, typically in the form of smaller tributary streams. The dotted line shows through flow, and that's water moving through the soil or rock. And that goes some way to explain why its peak is later than the peak flow of the overland flow, because this water has to make its way through soil and rock to reach the river. The dotted line at the bottom here, the dashed line, is base flow, and that shows the normal rate, the normal discharge rate of the river. Okay, the final feature you need to be able to identify is the basin lag time. Now, the lag time is simply the distance of time between peak rainfall falling, peak precipitation, and the peak flow in the river itself. In other words, the distance of time between the rain falling from the sky and then reaching the river. Okay. Now, before we get to the explanation side of it, it's useful to know that the scale at the bottom, here measured in hours from the start of the rainstorm, can be anything from hours to measured in days, possibly even months. So be aware of that. In describing any graph, you should always make reference to data from the graph. So make sure you reference discharge in cubic meters per second and the relevant units of time along the x-axis. Now to explanation. On the right-hand side of your screen, you'll see that there are various key points which you can draw reference to. The first is basin area. Now, basin area refers to the size, the physical size of the river basin. If it's very large, then it can capture more rain. That leads to more surface runoff, and therefore a faster rising limb. Basin shape. Circular basins tend to fill their rivers more quickly because there's a shorter distance between the river and its watershed. Elongate basins, that's oval shaped, tend to be slower, so they have a longer lag time. Rock type. Some rock types are permeable, for example limestone. In other words, the surface runoff quickly infiltrates down through the rocks. This would lead to a quicker through flow rate, but possibly a slower overland flow rate because much of the water is sinking down through the rock structure. Soil type influences things in a similar way. For example, brown earth soils drain well, and therefore the surface runoff will be reduced due to it infiltrating down through the soil. Whereas clays are largely impermeable, and so the water will sit on top of them and flow over them more readily. and that would give a shorter lag time. Vegetation. In areas where there's farming, lag times can be reduced. So that can mean shorter lag times due to irrigation ditches. Or though, if there was forestry intersects much of the rainfall and therefore increases lag time. Land use, that gets back to what I was saying there about farming, but also things like buildings, concrete streets, anywhere that has sewer systems, so that's any urban area, will speed up lag times, shorten the lag times, because concrete is impermeable and the surface runoff shoots over the top of it and straight into the river, or is even conducted down drains and sewers, rather like irrigation in farmers' fields. Drainage density. What this means is how many tributaries are there in the river basin. If there are many ways in which the water falling from the sky can be conducted into the river, then this will reduce the lag time. If there are few tributary streams for the precipitation to reach the river's course, then the lag time will be longer. Tidal conditions. If the tide is in, this can cause the river level to be backed up its course, and so the river level can rise, and this would decrease lag times. The final one, precipitation and temperature, is very important. Always check the time of year of your hydrograph. They very often come with a time of year. If it's in summertime, the soil may be baked hard, and therefore the surface runoff is more easily conducted over the soil, and lag times will be shorter. Similarly, in wintertime, the ground can be frozen solid, and the same can be said. There will be a shorter lag time because the surface runoff will flow over the top. However, you can also say that the rain may fall as snow, in which case the lag time would be much longer, because the rain would be trapped as snow and would have to melt before it could reach the river. Now, clearly you can't use all of these points in your answer. You have to be selective. So give this question a shot and check the notes on the website, check the notes in your books, and come and see me if you've got any questions. Okay, I hope that helped.